We're done.
Okay, great.
Nice work.
Thank you
Thanks,
very much.
Grant.
Well, okay, so you'll invite me then for that other thing you were talking
Absolutely.
about.
Yeah.
This was the interview, right? This was the test one. And
yeah, right. This is the
Grant,
this
I'm
is the
not really going to invite you. Actually, I was recording this. I think I started.
That's just at the bottom. I got it. That's what I'm saying.
Sorry.
Has been doing in building such a robust relationship through your interaction with not only the South African Space Agency, but your support of the endeavors of the Ministry of Science and Technology here. In fact, at the recent Sci-Fest in Grahamstown, Minister Pandor made a point to specifically not only thank NASA, but to thank Jim Adams for the tremendous job NASA has done sending not only astronauts, but from your great wealth and depth of scientific expertise that you call upon every day. I say to my audience here in Cape Town, as a U.S. diplomat, we love NASA because when NASA comes to town, people have these fond memories of their favorite television shows, like Star Trek or anything related to science. And it's also because our colleagues at NASA are really working on solutions to challenges facing our Earth. A colleague and myself sat in on Jim's lecture at Nelson Mandela Bay University not long ago, and there were in excess of 250, close to 300 students there listening to Jim talk about the Mars mission and the mission to Mars and what the mission to Mars can mean for us as citizens of the world. And it made me almost want to go back to school and study engineering. But I say almost. But again, thank you, sir. Please thank all of your colleagues for the wonderful job that they do, not only on behalf of the United States of America, but on behalf of science and scientific communities around the world. I'm going to have to duck out because, as you know, we have multiple events to attend, but I did not want this event to pass without coming down here just to say thank you.
Well, thank you, Mr. Consul General. And for those on the air who may not know, we have a past association. We consider ourselves to be brothers in the finest fraternity in the world. So it's always good to see you. And I ask you again, say hello to all my folk back in Columbia, South Carolina, when you go back to speak at Allen later this month or next month.
Real good. Thank you, sir.
Okay, thank you, Teddy. Right. Okay, so now we get to all the good stuff. As you all know, I don't sit and have a set of questions in front of me. It's more of a conversation. We're going to just chat about things that come to my mind, and we'll also pull some of the kids from the various schools. We've got schools represented from all over the world. I know that we have Mr. Flory's class there in Kansas. We have, let's see, Tanya's class, Cunningham in Pennsylvania. There we go, they're waving. We have Tanya's class in North Carolina. We have Michael's class in Pennsylvania. And we have Kim's class in Abidjan, Cote d'Ivoire. My French is absolutely awful. And of course, we have Beverly's class and Beverly is in North Carolina as well. And we hopefully will have our representatives from Rio, Suresh, and all of them joining us as well. But the first thing I'd like to do is start off by talking about Charlie Bolden, the man. Where did someone who is the son of two teachers, am I correct in saying so?
That's correct. Yes, you're absolutely correct.
Two teachers, lands up being the head of NASA. That's quite a journey. And from what I can understand, not just any head of NASA. I mean, you're the first black NASA head, which is a big deal from a role model point of view. It's huge. And not only that, but what I find fascinating is that you started off from very humble beginnings, and then you went the military route, and then you landed up doing NASA. But I want to know from you, where did it all start? I mean, were you a big fan of STEM-related subjects? What drove you to want to become an astronaut?
I was always a huge fan of STEM-related subjects, and I think my mom and dad had a lot to do with it. My mother was a librarian. She started in elementary school at the elementary level, then moved to the middle school level, and she actually moved into high school when schools were integrated in the United States back in the 60s. She was selected to be the first black librarian to go into a white high school in Columbia, South Carolina. I was her library assistant in middle school. She and my dad always talked about the necessity to study and study very hard. They encouraged my participation in science fairs and the like. And I guess to answer your final question is, I never dreamed of being an astronaut when I was growing up. In fact, that was something that I thought was out of the realm of possibility for me. So I came into the decision to apply for the astronaut program pretty late in life. We can talk about that a little bit later.
Wow. But your journey to becoming an astronaut, a Marine, was
Yes.
actually quite a fascinating one. You got to write a letter to the president. I mean, this is unheard of. Why would you need to write a letter to a president to become a Marine?
Well, for the students there in Cape Town, you can relate a little bit. When I was a kid, America was a segregated society, not much unlike, in some terms, like the apartheid in which South Africa experienced. But in the 60s, we decided as a nation that we were no longer going to live that way. And I had fallen in love with a place called the United States Naval Academy when I was in 7th grade. And I decided then that I really wanted to go there. I knew nothing about it. I knew nothing about the military. My dad and my uncles had served in the Army in World War II, but they never talked about it. So I didn't have any military background. But one of the requirements to get into the Naval Academy and the service academies in the United States is that you have an appointment from one of your congressional representatives, one of the 2 state senators, or your congressional representative, or for every young person in the United States, an appointment from the Vice President of the United States. When I tried to get an appointment, we still lived in a segregated society at the time, and neither of my 2 state senators nor my congressional representative would consider me for an appointment to the Naval Academy, and it was mainly because of my race. So I had been writing to Vice President Lyndon Johnson for a number of years, and as a last resort, in my senior year, President Kennedy had been assassinated, and so I knew that I was not eligible for a presidential appointment, but against all odds, I decided I would write to the president anyway and remind him that I had been communicating with him about going to the Naval Academy, and never got a response from him to my letter. But within a couple of weeks, I got a visit from a Navy recruiter, and then later a retired federal judge that President Johnson had appointed to travel around the country looking for qualified young men of color. Then I ended up getting an appointment from Chicago, Illinois, to go to the Naval Academy. So that's how I got there.
Wow. I mean, that takes a lot of guts to be able to do that. And I think that a testament to the fact that, if you really want something, you've got to fight for it.
And that's a message I give to students all the time. I have 3 things that I talk about. One is studying really hard and taking difficult subjects. I believe that if you take as much science and math as possible as you grow up, you'll have much more opportunity to select the area in which you want to work as an adult. That's not to say that you don't take math and science and you can't do things. That's not true. But I think you broaden your opportunity for job selection if you have a strong math and science background, in addition to the what I call the liberal arts, the language arts and the like. The second thing is working really hard in the classroom. Take your schoolwork as seriously as you do your music or your athletics. If you happen to be a musician or you happen to be an athlete, any of the young people who play any sports, the one thing that they know, their coaches always yell at them. It doesn't make any difference what the sport is, or a piano teacher is practice, practice, practice. You have to practice if you want to be good. And so that's what I mean when I say work hard. If you want to be good in the classroom, you have to practice. You have to work at it, which means don't ever leave a class without having a teacher explain something to you if you're not certain of what the material covered really entails or what it said. And then the third thing is don't be afraid of failure. And that means, and I got that from my mom and dad. They told me I could do anything I wanted to do as long as I was willing to study hard and work for it. But don't ever be afraid of failing. Failure is a critical importance of an important part of growing up and becoming a mature individual. So I would tell all the students who are involved in this conversation, never be afraid of failure. Don't let anybody else define you. Don't let anybody tell you what you cannot do. Make up your mind and then go for it. But prepare yourself through study and hard work.
Wow. Okay. So you obviously you had a very distinguished career in the military, and through various mechanisms, you obviously enrolled as an astronaut. What made you become an astronaut? What was the motivation to become an astronaut?
You know, we all meet people in our lives that we consider role models. I guess if I stopped and interrupted right here and asked any of the students sitting behind you there, you know, who's their role model, they might name a teacher, or they might name their parents. For me, among my role models happen to be my son and my daughter, because of the way that they have excelled in their lives so far and have been very successful. But in my particular case, I never dreamed of being an astronaut, as I said, and I really did not intend to become a Marine or to fly airplanes. But my role model, my very first year at the Naval Academy, became a young Marine Corps major who was an infantry officer by the name of John Riley Love. And he was my first company officer, the adult responsible for about 150 of us in a Naval Academy company. And so because I was so impressed with him, he was very much like my dad. He was very tough, but eminently fair. And I decided that year that, you know, he really impressed me. But little did I know how much he would impress me, because 4 years later, when I became a senior and I had to make what they call at the Naval Academy, my service selection, I look back and I love being on ships. I'd love being at sea. But I said, you know, I really want to be like him. I want to be like Major Love. So contrary to the fact that I said I would never join the Marine Corps, I opted to go into the Marine Corps. And I wanted to be an infantry officer. And in the Marine Corps, we're required to go through a 6-month course called the Basic School to be rifle platoon commanders. And I found in that 6 months that I really didn't like crawling around in the mud. I had done well enough in school at the Naval Academy to have an aviation option in my hip pocket. And so my wife and I talked about it long and hard, and we decided we should go to Pensacola, Florida, and I should go to flight school in spite of the fact that I said I never wanted to fly. And I did. First time I got in an airplane and we got airborne, I fell in love with it. I could not believe I had not wanted to do that. And then that led more and more to finding other role models, one of whom was a test pilot. So I decided I wanted to go become a test pilot. And it took me several years to do that, but I finally became a test pilot. And it was while I was serving as a test pilot that I met the late, great Dr. Ron McNair, who was in his first year as a NASA astronaut candidate. And like me, he was a young black gentleman. He had grown up about 40 miles from me in Lake City, South Carolina. But unlike me, he had known all his life that he wanted to be an astronaut. And he and I talked about what the training was like. At the end of it, I was mesmerized, but I still had not changed my mind. I had no desire to become an astronaut. And he asked me before he left if I was going to apply for the space program. I told him, not on your life. And he looked at me and he said, why not? And I told him, because they'd never picked me. And he said, you know, that's the dumbest thing I ever heard. And students, you listen to this. He told me that's the dumbest thing I ever heard. How do you know they won't pick you if you don't ask, if you don't apply? So for the students in the various classrooms, if there's something you want to do, you've got to ask for it. People are not going to walk up to you on the street and say, I'm looking for somebody to become a NASA astronaut, or I'm looking for somebody to become a South African astronaut, or I'm looking for someone to become an astronaut from Azerbaijan. You've got to ask for it. And that was the lesson I had forgotten from my parents, who had told me I could do anything I wanted to do, but I kind of forgot it for a moment.
Wow. Okay, so now, I mean, we fast forward a little bit. You obviously get to become an astronaut, and you didn't do one, you didn't do two, you didn't do three, you did 4 shuttle missions. Can you describe what it felt like that first time flying in that shuttle, going up? I mean, obviously it takes a while. You know that you've been chosen. A lot of training, you go through the training, but that sensation of knowing that it's not an aeroplane. This is like a rocket. It's a big deal. Can you talk us through that first experience?
There's a one-word description, which is kind of boring, but it's awesome. It is absolutely incredible. You go through a lot of different emotions over the course of, you've worked really long and hard. Training for a flight is usually around 2 years just to get ready for your flight. And then on launch morning, when you finally get strapped into the vehicle and you're laying there waiting for several hours to launch, you begin to go through these emotional ups and downs. And the first one for me was a sense of, I guess, anxiety. I wasn't afraid at all. There were so many procedures that I had to learn over the course of the 2 years. And as the pilot, the co-pilot on the crew, I knew that if anything happened, I was going to have to spring to action and do something to try to fix whatever was wrong. And I was very apprehensive about that. You had weak areas in your training, and you'd sit there and say, oh, please don't have anything happen in that particular area. So apprehension was the first thing. Then all of a sudden you get down to the final second before launch, and you can hear the countdown, the 10, 9, 8, 7, 6, 5. About that time, you feel this explosion. It kind of goes boom, 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 as the main engines on the space shuttle ignite. And they're strong, but they're not strong enough to lift the vehicle off just yet. And the vehicle starts to rock a little bit. So now you get this physical sensation that something's about to happen. And then in 5 seconds or so, when the computers say everything's all right, they send signals in the case of the space shuttle to 2 solid rocket boosters, and the signal lets them ignite. And then there is no question in your mind. You feel and you can actually hear the explosion of the solid rocket boosters. And they just go boom, and everything starts to shake and vibrate, and you can feel yourself sinking back in your seat, and you're lifting off. And it's a gentle lift off. You know, on the outside, you see all this fire and smoke, and you think it's got to be violent on the inside. But it's about a G1/2. So it's no more than you'd feel in a car with a teenager driving when they start from a sudden start from a stoplight or a stop sign. And you just vibrate for the first few minutes until the solids separate. And even today, on whether you're flying on a Russian Soyuz or any other kind of spacecraft, there is this vibration until the first stage rockets separate. And then you get onto the main portion of the rocket, which in the case of shuttle was the shuttle itself with its 3 main engines, and it's incredibly smooth. You're still accelerating, and there's not a lot of force on your body at all, but it's just a nice smooth acceleration. And in all the systems that we use today, it's about 8.5 minutes to get to space, and then by that time you're going 17,500 miles an hour, and you're in space. And when the main engine's cut off, all of a sudden you spring forward in your seat. You're pressed up against the straps because gravity is now overcome because of the speed at which you're going around Earth. And you find yourself doing what we describe as floating. You're actually constantly trying to fall back to Earth, but centrifugal force is opposing that and won't let you fall back, so you float. So you go from anxiety before launch to exhilaration, everything starts shaking and vibrating, to this calm and peaceful ride for about 6 minutes until you get to space. And then all of a sudden you go back to exhilaration again when the G is just relieved altogether and you start floating. And then you look out the window and there's this feeling of awe as you look back at our planet, all of its magnificence and majesty. and realize where you are.
Do you have like a set rule that once you hit zero gravity, that everyone's allowed to unbuckle and just float around just to get into it? Or I mean, can you imagine the
Depends on the
novelty?
spacecraft. Today, because we today go to space on a Russian spacecraft called Soyuz, and it's really like very tight. It's like the old Apollo, Mercury, Gemini, Apollo spacecraft. So the three crew members are really kind of crammed into the cockpit. With the space shuttle, it was big and spacious. So there, we agreed that once you got to orbit and you felt that you were no longer needed to be strapped in, you could release your straps, and you could very gently float up out of your seat to get to a window where you could see something. And the experienced space flyers always said, don't do anything dramatic. You want to, because your body, your balance mechanism, actually your vestibular system in your ear is really not accustomed to having no gravity reference. So that's the time that most people, if they're going to experience any discomfort or any what we call space adaptation syndrome, motion sickness, they'll experience it because they move radically. So in my case, I have been taught to move very gently. If you're going to move at all, move your whole body. Don't turn your head. Don't excite things that don't want to be excited. And so for me, my first few days were incredibly mild, and I didn't have any stomach awareness or anything. Just normal. It was just letting my body acclimate to being in space. So, but two things: the visual perception of our planet from the vantage point of space is breathtaking, unlike anything I'd ever seen, anything I was prepared for, and the physical sensation of having overcome gravity, being able to float. For the students who are senior enough or far enough along in school to have studied Newton's laws by now, all of a sudden you are the specimen in the laboratory, and you get to see and experience firsthand what Isaac Newton meant when he talked about a body at rest, staying at rest. You just stabilize yourself, don't do anything, you just float right there in midair. If you touch something like a computer keyboard, all of a sudden, for every action I'm pressing on the keyboard, there is an equal and opposite reaction. So I get fired across the cabin, and until I stabilize myself again. So you see Newton's law that says a body in motion stays in motion unless otherwise acted upon by an outside force. So you become a subject in a living laboratory, and we do that on the International Space Station even today.
Wow. But now you obviously, going on one shuttle mission wasn't good enough, so 4 you had to do, and of course you had to pilot one of them as well. So you actually flew the shuttle yourself, being an Air Force pilot, and one of them you actually delivered the Hubble Space Telescope.
That's correct. My second flight was the flight of the Hubble Space Telescope. And to kind of fill out the picture, my first flight occurred in January of 1986, and we came back, and I was sort of on this emotional high. 10 days later, we watched our friends in Challenger launch, and we lost Challenger. That was 10 days after I came back, we lost the Challenger shuttle, and the program was shut down for a couple of years. That was, and again, for the students, when I talked about don't be afraid of failure, everybody that goes to space knows that you incur risk in doing so, but it's worth it. And you'll have to convince yourself that what you're doing is worth it. A decision I had to make almost immediately after we lost shuttle was, is this the right area for me? Do I want to be in this business? Do I ever want to fly again? And it took me about, I always tell people, it took me about a nanosecond to think about it and say, of course I want to fly again. That's why I came here. And it would be an insult to my fellow member of the astronaut corps who had just perished. I decided all of a sudden this wasn't worth it. So I felt I had an obligation to them. Plus, I really wanted to continue with this journey into the unknown, or going back to space. And that's why I flew 3 more flights.
Wow. Okay, but now the shuttle mission was obviously quite exciting. So you maybe felt that maybe I should get a little bit more involved in NASA. I mean, being an astronaut is great to add onto the resume. What could I do next? So how did you get involved with becoming the head of NASA?
It was long and unintentional. One does not plan to be the NASA administrator. I I am a political appointee, which means that the President of the United States, in council with his advisors, decided to talk to me and kind of pick my brain about NASA and where I thought the agency should be going and everything. And it was not it may have been a job interview, but I did not know it at the time. And it was not at all an interview for him to tell me, okay, I've decided I want you to be the NASA administrator, because that did not happen. We talked for about 15 or 20 minutes in the Oval Office. And at the end, he thanked me for coming in, and I went back home to Houston, Texas. And my wife and I went back to our business. I had retired from the Marine Corps about 6 years prior to that, and we were having a good time. And several months later, I got a call from an office called White House Personnel, or Presidential Personnel, saying that the president had decided he wanted to nominate me to the Congress to be the NASA administrator. So quite surprising, but that began a trek of several months where you then have to go in and meet with members of Congress and talk to them and answer their questions and everything, and then go in for what we call a hearing. So the Senate Commerce Committee is the committee in our Senate that confirms appointments made by the president. So I went through a hearing with the Senate Commerce Committee, and they decided that afternoon, actually, that I was acceptable. So I was voted out of committee, then voted out on the floor of the Senate. And the day after my hearing, I was sitting in my office as the NASA administrator. So it was sort of like, I can't say it was a dream come true, because I never dreamed of doing this. But it is incredible. It's an incredible, exciting opportunity for me to contribute to the future of the world in terms of exploration and aeronautics and science. Yep, you just got muted, Steve. You just got muted.
Yeah, no.
Okay.
I've been muting myself when you speak. What I found interesting is that most of these things you never intended, but you landed up doing them anyway and having a great time. So maybe a good message to young people is, if you climb out of your comfort zone and you experiment and try things, you never know. You might find that you fall in love with something that you want to do.
I'll echo your message. I tell students all the time, when you're thinking about what you want to do in life, find out what it is about which you're passionate. Find out what it is that excites you and really turns you on, and then follow that. Don't listen to your parents. Don't listen to a teacher. Don't listen to somebody else who assumes that they know what's best for you in terms of what your life's work is going to be. Be respectful and have a discussion with them, but only you can decide what's going to be right for you. And my son and my daughter and I have had these conversations a lot, and they both chose the path that they wanted to follow, and they're happy. They're excited about what they do. I did the same thing. I was passionate about wanting to go to the Naval Academy, and I got there and found out I hated it. It was hard, and I didn't hate it because it wasn't a good place. I hated it because it was really hard. So I did the same thing that a lot of students will do. I told my mom and dad I wanted to come home. It was too hard for me. And my father, who had been my high school football coach, American football for most of the kids there, not in the United States, he would tell me every week when I called, he said, hang in there one more week. And that's probably the advice that a lot of the parents would give you students. If you ask them, they'd probably tell you, don't make a rash decision. Hang in there just a little while longer and see if it takes. And that's what happened to me over my 4 years at the Naval Academy. I found that I really enjoyed what I was doing. I was absolutely right about that being my passion. And then, as I said, I made the decision to go in the Marine Corps. And it's a decision that I never look back and I never regret, because that was next to NASA, that's probably the greatest experience I've had in my life, is being with Marines and leading Marines and having an opportunity to learn from them and hopefully have them learn from me.
Wow. Well, I mean, what I always think too is, you're obviously a shuttle pilot. You've flown several missions. They now put you in charge of NASA, and then they ask you as one of your first jobs to retire the shuttles. I mean, how did you feel about that?
It was the right thing to do, and I knew it was the right thing to do. So while the decision to take the job, I kind of halfway figured that, since the president and I had talked about the future, and he and I had talked about the desire to see humans go farther into the solar system, without saying it to each other, I think we both realized that NASA could not lead the world in exploration and discovery beyond low Earth orbit if we were not willing to give up on the space shuttle and move on to something bigger that would allow us to leave low Earth orbit. And so when that decision was made, and the decision actually had been made years ahead of that. It was actually made after we lost our second shuttle, Columbia. There was an accident investigation board that reported out to the NASA administrator and the president and the Congress, and one of their recommendations was that we should phase out of the shuttle over the next 10 years. And so the president told me that he wanted to go ahead and execute that plan that was actually generated by President Bush, his predecessor. And so that's what we sought to do. And we told the team we wanted to make sure that we did it in the safest way possible. We wanted to safely and successfully phase out of the shuttle. And we managed to do that in the summer of 2011 and immediately pick up on the next step, which was to try to go farther into the solar system than we had ever been. We already had the International Space Station on orbit, so we decided to use the shuttle to complete its construction, and we did that, finishing it in 2010, which then gave us, you know, it said, okay, it's now okay to retire the shuttle, because it was the workhorse of getting the construction crews up to build the International Space Station. And once that was done, there was not a strong need for a vehicle that big to do that. So we're now developing something that's called the Space Launch System. It's a heavy lift launch vehicle, and a crew module called Orion that looks, it's conical in shape, looks a lot like a larger Apollo module. And that's what we're going to use to carry anywhere from 2 to 7 crew members to deep space. And our first plan is in the early 2020s. We'll fly the first flight on the SLS and Orion in 2018, probably October of 2018. That'll verify that the system is able to work. That'll be an uncrewed mission. And then in the early 20s, 2021 or so, we're going to put humans in. We're going to put a crew in. And then we'll fly a mission out to the moon again, do some orbits of the moon and some work out there. And that will begin a 10-year period of time where we're going to be demonstrating the technologies, finishing up the development of technologies, but also answering the final questions we need about the human body and whether or not we're ready to go to Mars. And then in the 2030s, we're going to move one step farther, and we're going to send humans to Mars, utilizing not just SLS and Orion, but teaming with our commercial partners that we have helped to develop over the course of time. We now don't, without the shuttle, we carry cargo to space today on 2 American spacecraft, the Dragon, built by a company called SpaceX, and the Cygnus is a company called Orbital ATK from here in Virginia, but their vehicle is actually built in Italy. So we have now involved the international space community in providing cargo transportation to low Earth orbit while we work on transporting people into deep space, to the moon, to asteroids, and on to Mars.
Now, as obviously the administrator, you get to oversee many of the projects, and you've seen how technology is developing, but you guys have to plan well in advance. I mean, to fly by Pluto with New Horizons, you sent a probe 10 years ago with the technology from 10 years ago. It eventually landed up flying past Pluto. You got the most magnificent footage and photographs, and that was 10 years in the making. But what is ironic is that there are private individuals who are now starting to develop things that are going to shift your timelines dramatically. So you might be planning for 10 years' time, but they might have something that is going to be ready in 5 years' time. In fact, there are some countries who are talking about launching their rockets, possibly even getting to Mars before America. What do you have to say about that?
It's really important that people have those types of visions and aspirations. We work very vigorously with our international partners, and we have 5 big partners today who help us on the International Space Station. They're the Russian Space Agency Roscosmos, the Japanese Space Agency JAXA, the Canadian Space Agency, and then the largest partner is the European Space Agency, which is made up of 22 European nations. And so all of us have agreed that our primary focus for humans is Mars, getting humans to Mars in the 2030s. But in the interim, there are a lot of different things that we all want to do. If you talk to our European allies, they really would like to expend some of their assets to go to the moon, to do some human surface operations on the moon. We think that's really, really, really important, because in the limited funding that's available for the space programs throughout the world, we all have to capitalize on what we individually can do. So we spend a lot of time in groups like, we have one group that's called the International Space Exploration Working Group. We have the International Space Station Working Group. So there are a lot of working groups that bring nations together. One of the most recent entries into this family of exploration nations is the United Arab Emirates, UAE. In conjunction with their 50th anniversary, they want to send a mission to Mars, an orbiter that will go to Mars. And so we're collaborating with them. We're providing engineering support for them. We're teaming with them to make that mission possible. India became only the first nation in the world to ever reach Mars on their first attempt almost 2 years ago, when they launched a mission that's called the Mars Orbiting Mission, or MOM, and it got to Mars 2 days or so after a mission that we had built called MAVEN, that's looking at Mars's upper atmosphere. So we plan those two missions to be collaborative and cooperative. So we work with the Indians to help them get to Mars. Their mission looks at the Martian atmosphere, but we look at it in much more detail and in a much more diverse way. So we team to capitalize on the capabilities of each other's instruments so that we get more answers for humanity. So that's what we're doing, and we're excited, really excited about having private entities, companies like SpaceX, organizations like Moon Express, and some that people haven't even heard about, who come to us and say, we'd like to try to do this. And we say, hey, go for it. Let us know what it is we can do to help you, whether it's borrowing our facilities or our engineering expertise, and we'll try to facilitate your success. This is something for humanity. You know, going to Mars is not an American venture. It is something for humanity. And so for the students there, you know, I hope all of you will dream about going to Mars, or if not going physically yourself, about doing an experiment that's going to be flown on a spacecraft that's going to end up on the surface of Mars and answer some really critical questions that are important to your community wherever you come from. You know, looking at, and I don't want to drag this out, but we work with a lot of third world countries, and we look at things like river blindness. These are the kinds of science endeavors that we use the data that we get from space to make it available for them, so that we can attack human diseases and human pathogens that kill young people every day in hundreds. So we're working with nations throughout the world in the areas of science, aeronautics, space technology, and human exploration, because we want as many nations as possible to participate with us. Unmute.
Sorry about that. It'll take a while to get used to. We've got a bunch of schools that have obviously joined us, and we've got Suresh and his team there in Rio with the Astronomical Society. It says Goethe. I won't even try to pronounce it, but they are celebrating Louis Krull's Astronomy Club there. That's 20th anniversary. And I'm going to ask a couple of the schools if you could just pick one student in your group that would like to ask a question, and then during the course of the interview, I'll just put the flashlight on you and ask you to select that student to stand up and get a chance to ask the administrator your question. What I would like to know is...
My answer is very succinct, so if I don't cover what you asked, come back and ask it again, because I'm going to try to make the answer short.
Okay. What I do want to know is there's been a lot of talk. Stephen Hawkins and his group have just put together a very bold plan about sending a probe very, very distant into the universe. We've also got, obviously, the success of Elon Musk and Bezos with their various projects. Where do you see us heading, apart from going to Mars? Where do you see us in the next 15 to 20 years? Because I think Mars is going to happen sooner than you think.
I hope you're right. Although the next 15 or 20 years is when we're talking about being at Mars. That takes you to the 2030s. Anyway, but I think we're going to follow the example of missions like Pluto New Horizons. New Horizons is already on its way. It's in the Kuiper Belt now, which is beyond Pluto. And we're looking for targets in the Kuiper Belt. So it's like Dr. Hawking has said and others, um, this is a human and robotic exploration endeavor. And robotic spacecraft, will go much farther into the universe than humans will be able to do in the foreseeable future. So while we try to get humans to Mars, we're trying to get our robotic spacecraft to actually leave the solar system, get into interstellar space. And so Voyager is one that's already left the solar system and is out in interstellar space. New Horizons is out in the Kuiper Belt beyond the planets of the solar system, and we intend to mount many more missions like that, missions to study our sun, looking at innovative technologies that enable countries that would not otherwise be able to do space exploration to take part. Why Mars? You unmute. I think you said why Mars.
You could lip read very well.
I did.
You're
Why
going to be
Mars?
speaking at the Humans to Mars Summit, which I'm involved in from an educational point of view. We're going to try and promote a lot of the speakers to an international audience like this. And the big question is, why Mars? I mean, what is so special about Mars? And why is there all this excitement? Obviously, the movie, The Martian, Andy Weir's book, has generated some interest, but there seems to be a huge impetus, a huge growth towards heading to Mars. What is the big deal?
Mars is very special for one particular reason, is because we believe it is most likely, it is the most probable planet in our solar system that that harbors life today or once harbored life and could sustain human life. Now, it won't be like living on Earth. So that's one of the reasons why Mars. It will hopefully answer our search for, are we alone in the universe? And there are other places that are now coming into view, though, because we're talking about microbial life. We're not talking about somebody like you and me, Steve. We're talking about a form of life. And so large moons, what we call water moons, Enceladus around Saturn, or Europa around Jupiter. We're designing a mission right now, even as we speak, to send a robotic spacecraft to Europa that will map the planet, map the moon's surface, help us decide on where we can go with future missions to put a robotic lander down there and actually drill through the ice to sample the water in this giant ocean moon to see if there is life there. And that's the same whether you're talking about Enceladus or Titan around Saturn or Europa around Jupiter. So the big reason to do a lot of this stuff is to help us determine, are we alone in the universe? The other big reason is because we want to know more and more about our own planet Earth. And Earth actually had the same, because we all had the same beginning back in the day of the Big Bang. Every time we capture something from an asteroid or we learn something new about Mars, that's something else that we learn about our own planet Earth. So it helps us to understand the origin of our own planet and its makeup. And in the case of somewhere like Mars, that we believe used to be fertile, not very much unlike Earth, what happened to it? Could that possibly happen to Earth? As we look at changing climate today, are we in danger of becoming like a Mars? We hope not, but we don't know that. So our Earth science people are always looking at the way that our climate is changing across the globe.
Welcome.
And what we want to know in that case is are there things that we as humans are doing that exacerbate that change? Because everybody knows that Earth goes through cycles, but is having humans down here doing all the things that we do as we advance technology, are we perhaps doing something that's contributing to the worsening of our environment?
Okay, all right. Now we're going to cross over to Microsoft Skill. He's got a group at Wallen-Porpak School in Pennsylvania. Mike, do you have one of your students who would like to ask a question nice and loud? You're going to have to unmute yourself. There we go.
What is the most exhilarating sight you've seen in space?
I'm sorry. Don't run away. Don't
Come
run
back,
away.
You're going to have to say it
Come
again.
back and ask your question one more time, and let me make sure that you're unmuted so that I can hear your question. Now go ahead and ask it again.
What's the most exhilarating sight you've seen in space?
what's the most exciting thing I've seen, or the most unusual thing?
Unusual.
Oh, unusual. Everybody, believe it or not, I will admit, every astronaut is always looking for signs of life. To date, as far as I know, nobody's actually seen anything. But the most unusual thing that I think I have seen until it was explained to me was huge chunks of ice coming up behind the space shuttle as the ice evaporated, or actually it does something called sublimates. It goes all the way from solid to gas without going through a liquid state. And you'll learn about that later in school. And you see this stuff float up behind the shuttle, and immediately you didn't know what it was, so you'd start asking questions of the folk on the ground, and they'd go through an elaborate process of analyzing and everything, and you find out it's just chunks of ice that have broken off the back of your spacecraft. That's kind of unusual, and it fits into the category of things, you know, we commonly call unidentified flying objects, and that is a general term that we use to describe anything that you see, whether it's in space or in the air, that you don't know what it is. And so, to my knowledge, we've not had any unexplained, unidentified flying objects to date. But that would be, you know, that just tells you how mundane flights can be sometimes. I've not seen anything extraordinarily unusual.
That was a good question. Now we're going to switch to Kim out in West Africa. Kim, do you have a student that would like to ask a question? You're going to have to unmute yourself.
Okay.
I have so many. I don't know.
Do you want to pick one?
And Kim, where are you in West Africa?
We're in Cote d'Ivoire. We're right on the west
Oh,
coast,
yes. Okay.
not far from Ghana.
Okay.
And it's
So Ivory Coast.
Yeah, we're in
Yes.
Abidjan. So this is really wonderful. I'm going to bring Iman up. This is very hard. He raised his hand first just now, but before there were about 20 kids raise their hands.
Don't be worried, Imana. Ask your question. You're good.
Look up here.
So, are we going to go anywhere else than Mars?
Oh, are we going to go anywhere else other than Mars with humans, or just humanity using robotic spacecraft? Which, or do you mean both? With humans? Yes. On the way to Mars, there are other heavenly bodies that we intend to visit. In fact, before we get to Mars, we will probably have, because we're working with other countries and with private entities, we'll probably see humans back on the surface of the moon again. In our case, in NASA's case, we have a mission that we call the Asteroid Redirect Mission, where we're going to send a robotic spacecraft out, probably launch it in the next 3 to 4 years, and it will rendezvous with an asteroid that is going to pass close to the Earth, and land on it and get a giant boulder off that asteroid, and then take off again, and over about 1.5 years try to push against the asteroid to get it closer and closer to the moon, where our moon draws it into its gravitational field, and it gets into a stable orbit around the moon, so that astronauts can then go to the asteroid or the rock from the asteroid and begin to do things like mining material off that rock. And remember, when he asked me earlier about why Mars, I mentioned the fact that with asteroids, the moon, Mars, all of them originated the same place, our own Earth. So as we get samples from the asteroid, we'll learn more things about our very own Earth. So, you know, asteroids, Mars, moon, all of those are coming in your lifetime. And if you study really hard and work hard, you may actually be one of the people that has an opportunity to go do that.
Okay, we're now with, I think, Tanya Fletcher.